This is my second attempt. Good morning, David Paul. Yeah, this is my second attempt to video this. It's raining, so I think the rain hit the screen and switched it off. So I'll talk quickly. Okay, these beams are monstrously heavy, and I'm here all on my own having to work them. So that's going to be a beast. I've got to select 6 straight beams, really the best of the batch. And then the idea is that I will drill holes through 2 sets of holes, and also miter the corners of them, so that I can make 2 equilateral triangles. If you can imagine that the device that you have for setting balls up on a pool table, an equilateral triangle wooden box thing, that's what I'm trying to make, is 2 of them, but on a monstrously large scale. So you build one, and then you build the second one, and you stand them on top of each other but out of sync, so that they form, when you look from the top, they form a sort of Star of David kind of pattern. Then I have to drill through. Well, first I got to drill through so that they can be bolted together. And I don't know if it's raining, but no, it's not. It's the water off the trees. Bolted through so that they form like a hexagonal centre, and then at the corners they're mitered and nailed through initially, and that's that. And the idea is that at each corner they'll be supported by trees, so it's kind of a tree house which is not in the trees. So it's basically a tree house which is only like 2 feet off the ground, or 3 feet, or whatever the hell you choose, you know. But it's, or even nothing, you know, you can just drill it into the side of the tree at base level. But that means that you've now got a tree as your support, and you don't have to worry about like critters and stuff coming up through the floor, drilling into the tree, and eventually they'll obviously things will eat the tree. But what happens is, as the tree gets bigger and bigger and bigger at each of the 6 corners, it starts to intrude on the house. So what you do is you cut down a tree, or 3 trees at most, and then the house is still supported on the 3 supports. And I got this idea. I was in Isaac Newton's house. I'd gone down there with a friend, and we were looking at stuff, and he just pointed at a chair, a stool. He said, "You see, look, 3-legged stool. You know why they're like that?" I said, "No." He said, "Because they never had level floors. So instead of going tick, 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 tick like a 4-legged one would do, a 3-legged one will always stand. At least it'll stand, and then you could put something under one leg to level it up." So the moral of the tale is 3-legged structures. Okay. But of course, when you take the 3 legs away for renewal, then you've got a no-legged structure. So what you do is you have a 6-legged structure, and 3 of them at any one time are providing the main support for the house, and that's that. That's the plan. And then from that you can extend out in all directions and do what you like. So, initial problem is me handling these big logs, turning them, measuring them, and that's that. So flip them over, and I'm going to make 2 drill holes in each log. That's 12 drills, 2 sides, 24 drill holes, plus the mitering on the corners. Quite a lot, actually. If I get that done today, I'll be amazed. That would be amazing. Well, let's see. There is not a snowball's chance in hell that I can get these logs, these beams rather, and carry them up to the site. So maybe tomorrow I'll get the workers back and get them carried up. And then once that's started, we're moving. The rest of the wood, when I make other structures, I'll probably be cutting the wood down to smaller lengths, which I can maybe handle, you know. We'll see. Lots of wood here, lots of wood over there to get working with. So, better get started. Atilago matitatayo sakana. See you later. Jesus be with you.